Assembly language explained. In simple words, what does assembly language mean? Assembly language is a low-level programming language that is very close to machine language and directly communicates with the computer's hardware. It uses short words, called mnemonics, instead of zeros and ones to represent machine instructions. In simple words, assembly language equals human-readable form of machine language. It means, assembly language is a low-level language, close to hardware, uses short commands like mov, add, sub, converted into machine code, different for each CPU type. So, assembly language equals symbolic machine instructions. Example idea, mova 5, add a 3. Here, mov means move, add means add. Instructions control CPU directly. This is assembly-style thinking. Why it matters. Without assembly language, cross-mark only zeros and ones would be used. Cross-mark programming would be extremely hard. Cross-mark hardware control would be impossible. Cross-mark OS and drivers could not be written. Cross-mark debugging hardware would be difficult. With assembly language, checkmark easier than binary. Checkmark direct hardware control. Checkmark very fast execution. Checkmark useful for system programming. Checkmark helps understand how computers work. Real-life examples of assembly language usage. Assembly language is used in operating systems, device drivers, embedded systems, microcontrollers, firmware, performance-critical programs. How assembly language works. Step by step. You write assembly instructions. Down pointing arrow. Assembler converts them. Down pointing arrow. Machine code is created. Down pointing arrow. CPU executes the code. Flow. Write means assemble means run means execute. Features of assembly language. Assembly language. Hardware dependent. Very fast. Uses mnemonics. Direct memory access. Small program size. No abstraction. Full CPU control. It focuses on hardware and performance. Types of tasks done using assembly language. Assembly language is used for bootloaders, embedded programming, hardware control, performance tuning, low-level utilities, system-level programs, comparison with other language types. Machine language. Only zeros and ones. Hard to read. Fastest. Assembly language. Uses words instead of binary. Easier than machine code. Still hardware dependent. High-level language. Easy to read. Hardware independent. Slower than assembly. So, machine equals binary. Assembly equals symbolic. High-level equals human language. Common beginner mistakes. Beginners often forget CPU architecture differences. Misuse registers. Confuse memory addresses. Write long code. Ignore stack usage. These happen because assembly works very close to hardware. Good practices in assembly programming. Checkmark write small programs. Checkmark comment every instruction. Checkmark understand CPU registers. Checkmark test carefully. Checkmark use meaningful labels. Checkmark avoid unnecessary instructions. Real-life analogy. Assembly language is like talking to a robot using simple commands. Robot commands. Move, turn, stop. Computer commands. MOV, add, JMP. So, assembly equals robot instruction language. Important point. Assembly language is very powerful, is very fast, is hardware specific, teaches how CPUs work, is used in system-level programming. Without assembly language, crossmark no hardware level control, crossmark no OS kernels, crossmark no embedded systems, crossmark no firmware. Simple definition. Assembly language equals a low-level programming language that uses symbols to represent machine instructions. Summary. Assembly language. Checkmark works close to hardware. Checkmark is faster than high-level languages. Checkmark uses mnemonics. Checkmark gives full control of CPU. Checkmark is important for system programming. Without assembly language. Crossmark only binary programming. Crossmark very hard coding. Crossmark no hardware control. With assembly language. Checkmark easier than machine code. Checkmark direct CPU control. Checkmark efficient programs. Checkmark better understanding of computers. Checkmark foundation of low-level programming.